Well, welcome everybody to the Raspberry Pi Computing Education Research Seminar Series, the first back as we're going back to school in 2023. I hope everybody's well and is surviving. Thank you ever so much for coming along. I'm Jane Waite and I'm chairing today's seminar, and I'm really excited to welcome you to our 7th in our series on primary K to 5 computing education research. And so that's about children who are from 5 to 11 years old. And together we're going to explore how research can help us to support these young learners and, importantly, you, their educators, their teachers, in the learning of computing. So I'm now going to introduce Luisa. So first of all, Luisa, thank you so much for coming along to present. I've met Luisa several times before. She's a researcher from the University of Passau. She has a background in primary school education and media computer science and is currently part of the primary programming project at her university. Her research is focused on engaging children in programming and finding better ways to give feedback to these very young learners. And as we know, that's not always easy. She's passionate about education and she regularly holds creative computing workshops and courses for primary school children. And I'm personally very excited, but we're all excited here to hear about Luisa's recent work on programming education, where she's going to focus on telling us about effective feedback strategies to promote positivity among young learners.
I'm happy to be here and talk about feedback. And as Jane already said, it's not always easy. On the right-hand side, you can see me and my colleague Florian. We are in this case, 2 girls, but normally as a teacher, you have like 20 to 30 children, and it can be quite challenging. Still, we are doing it because on the left-hand side, you can see that the children really are interested. They like to engage with, for example, the robots, and you really know what you've done afterwards. But we also made a survey about these challenges. And we found that even experienced teachers really have a hard time and came up with this huge list of challenges. And many of these challenges are also associated with feedback. So when we give feedback, we have to have a lot in our minds. For example, maybe the children aren't developed in their literacy, or it's really hard to get around all children and supporting them individually. And programming is often seen as quite complex. I also think so, but as Jane already said, I will also introduce some tools to you, and maybe they can help. But we asked these teachers who have some experience in teaching programming, and they told us, well, they aren't aware of them. But when we told them what it was, they said maybe this can actually help. So the teachers agreed that analysis tool might support them with giving feedback to the students. So when I'm talking about feedback, I mostly mean formative feedback. And here you can see our project Primary Programming, where we really are enthusiastic about trying to evaluate these tools. And on the left-hand side, you can see my supervisor, Gordon Fraser, and he and his chair of about 10 research assistants put really a lot of work in these tools. These tools are mostly for Scratch and educational purposes, but we also have tools for, I think, Java and Python. Yeah. And so the computer science education department then uses these tools, evaluates them, reflects on them with teachers and children, so that we can really iteratively improve these tools. And I'm going to present one tool in more detail today. So because I think the most work has until now been put into this tool. If you're wondering where the name comes from, well, you know that the main sprite, the main figure of Scratch is a little cat. And therefore, everything is around this cat cosmos. And therefore, we decided to call our tool Litterbox, because we put a like smelly program into Litterbox, and afterwards, it's a little bit cleaner. It's also important to say that Litterbox isn't a solution for all problems. It looks at the code and detects patterns, but it doesn't include any task-specific information. So it can't tell you, for example, if you want the cat to go to the right, Litterbox won't tell you that, but Litterbox can tell you about certain patterns. And here you can see a list of patterns. I think my colleagues started in 2020 to collect patterns from their own experience. So they did many programming courses for children and realized, well, there are patterns that indicate bugs, and so we called them bug patterns. But they also looked manually through a lot of programs and then realized that some of the failures, so when the program fails, can be a result of such bug patterns. But we'll have a closer look later. Here you can see the list of bug patterns and also code smells that indicate a rather bad readability, and also good code, and we call them perfumes in contrast to the smells. So those are the three main categories. Bug patterns and smells are bad categories, and the perfumes are the good code pattern category. As you see on the right, I've now have opened the English version, but it's also available right now in, I think, German and Spanish. So what does Litterbox actually do? We are here having our program. On the left-hand side, there's a code which looks quite correct at first glance. And if we touch the fish with the star, or the other way around, we want that the points are changed and that the star goes to another position. But as we see, nothing happens with the points, nothing happens with the star, it doesn't go anywhere. And maybe you've already seen the bug, but maybe also not. And there is where Litterbox comes into place. And there you just have to upload your file. You could also do it with a publicly available project URL, but you don't need any further information. Litterbox analyzes the code and then provides these patterns. And indeed, we're having a bug here. So this bug is called the missing loop bug pattern. Well, because there's a loop missing. And we'll have a closer look at this specific hint. I'd ask you to just read through the hint. And every Litterbox hint is structured quite the same way. So here we're having feedback on mistake. And then in the second row, we are having feedback on concepts. So it's actually an explanation of the underlying concept. So in this case, how sequences and conditional statements and loops actually work together. And in the end, we always have feedback on how to proceed so that the learner really knows what to do next. The primary school teachers in training had to debug a total of 14 tasks. And half of them received Litterbox hints and the other half didn't. And this was what a typical task looked like. So we're having a fictitious student telling what's wrong. The teachers had to download the buggy program and uploaded the correct program. They then gave feedback to this fictitious student. And as debugging can be quite frustrating sometimes, we also prompted them to take breaks in between. So the first 7 tasks dealt with 7 different bug patterns. So for each task, there was 1 bug pattern. And as I said, only the treatment group received Litterbox hints. By this, we could find out how did they perform and if our hints are actually helpful, because we were not sure about it, because Litterbox only looks at the code and doesn't always give very much information. And then we wanted to see if they learned something with or without hints. And therefore, we had another 7 tasks with the same 7 bug patterns in tasks 8 to 14. And there, no one received hints so that we could see if the learning opportunity with or without hints was better. But at first, we'll have a look at the performance, so how well the hints were working. So here you can see for each of the 7 tasks, how many percent of the teachers submitted a correct solution, both for the control group and for the treatment group. And just think briefly about what results you would expect. And now we can see, well, the hints worked quite well as on the right-hand side, the treatment group mostly performed better. However, I think it's quite interesting that that's not the case for every task. So for 5 tasks, the difference was significantly different. But for 2 tasks, it wasn't. For task 1, treatment group was only slightly better, and for task 5, the hint even impaired the performance. So the hints seem to be very confusing. We'll therefore have a closer look at these 2 hints. So both hints deal with messages, and the hint for task 5 deals with the message never received bug pattern. Maybe if you're familiar with Scratch, you know that you can send messages between the sprites and the scripts. And Litterbox has detected here that a message was sent somewhere, but it was never received. So maybe just have a short look at the whole hint. And the main problem here is that Litterbox cannot state where this other script is where the message has to be sent. So here we're having the sprite coins, but we don't know where to receive this message. And this seemed to really confuse the teachers. For example, the bug has to be fixed in the sprite girlfriend, and the girlfriend is not at all in this hint that we see above, and not in the coins. Hence a somewhat misleading hint. And for us as researchers and also developers, we knew that it's really important to have the location where the bug has to be repaired. Of course, this cannot always be done, as for this hint, but then we at least have to state, well, for this hint, we can't tell the exact location of the bug, but only the location actually of the source of the bug. Another hint that was a little bit confusing is for the message never sent. So a message was received somewhere, but Litterbox has detected that it was never sent. And here on the right-hand side in the script, you see this little arrow, and there's a drop-down menu. And actually, you would only have to open this drop-down menu and select another message. But the problem here is that we're having 2 possibilities to repair this bug. And this seems to be a little bit confusing. As I didn't know exactly what to do, instead of game over, I added the gardener's message, ouch. This is actually also correct, but it seems to be confusing. So we realized that it's better to have only one solution approach. And if we're having several, we should structure them better. But luckily, in general, most hints have helped. And it's actually quite interesting for us to also see what kind of hints didn't help and why. As primary school teachers in training in Bavaria don't have to take any programming classes for later teaching in primary schools, we were happy that we could integrate this, and we were also keen on them learning something with the hints. So we didn't only want to see if our hints work in the first place, but also if they have learned something. And as I've said before, here in the task 8 to 14, the same 7 bug patterns were used. And we can see here that the differences really decreased a lot. So while we were having rather huge differences for the performance, for the learning, they were very small. And actually only for task 14, there's a significant difference. Maybe we thought about maybe this might be because for the other tasks, it might be quite hard to transfer the link because the primary school teachers in training only saw the hint once and debugged only one program with it. And I realized for me, it's quite good to have all these patterns in mind and then debug with the children or let them use individualized hints. But I think that currently Litterbox is not a version for primary school children, but we will later talk about a primary school version. So it seems that only for task 14, the hint could be transferred. And the hint was for stuttering movement. It's quite a large hint, as you can see here. You don't have to read it all through. But it seems that having this large hint on how to proceed was really helpful to transfer this hint. So with the step-by-step instructions, I was able to repair the bug in an easily understandable way. So for us, it seems important that when you have to repair a lot of different things, and there are many different steps, a hint is really crucial to actually repair a program. So for us, it seems important to then have a really detailed feedback about how to proceed. And all this led to some considerations for us on how to actually develop tools. Another idea where to use Litterbox is task creation. I think that's not the first thing I thought about when I heard about Litterbox, but we all know how it is when we are creating tasks and it takes a lot of time, and then there might still be a bug in it or a smell, and therefore you could use Litterbox and reduce the smells. And I think it's really important to have good example code, because while the students adapt our programming behavior and then think maybe a large script is normal, and they maybe also don't have any strategy to make their code more readable. And so we performed an experiment with about 60 teachers in training. And they created a programming task consisting of a task text and, of course, a Scratch program. And the task text you can see on the left-hand side was a template we gave them, and they then just had to insert their own task text. And again, only group treatment used Litterbox, and the other half didn't use Litterbox and therefore didn't receive any additional help. Why did we do this? Well, especially for primary school children, it's really helpful to have some scaffolding, because otherwise, if you would give them a whole program, they might be overwhelmed. And if you've been here for the other research seminars, Jean Salak talked about her tip and see approach, or here you can also see the Prim approach, that's also very popular. And all these approaches have in common that you give a program to the student. And this program has either to be selected by us, or we have to create it on our own. And the idea is now to kind of help us to create a program with the help of Litterbox. And interestingly, no negative effects were found indeed. So there were a lot of not significant influences, such as on the procedure or on the time, because we were a little bit concerned that uploading your program, reading and understanding the hints takes a lot of time, but it seems that it didn't take any more time. There was also no significant influence on, for example, the program size, the code perfumes, the task type, the number of subtasks, and the topics. And we at least found two positive effects. As we expected, the treatment group put way fewer, so significantly fewer code smells and bug patterns in their programs. This is useful, as I said before, because the children might otherwise adopt a bad programming habit. But as I said, this was quite expected. But interestingly, the treatment group also inserted more hints into their task text. So as you can see here, next to the light bulb, there's a little hint. And while in the template, there were only about exactly 2 light bulbs and hints, here we see 3. And this was quite common for the treatment group. And so it seems that when having received hints by Litterbox, you realize that while hints can help me as a teacher, then it might also help my students. And you also get some inspiration of how to build such a hint. But we also realized and got told by the teachers that, of course, Litterbox doesn't solve all the problems. So there's further needed support. For example, where do I start? Where do I get inspiration from? Also, sprite selection was a huge topic, and also adapting the material to the learner's needs. And I think in 1 month, Catherine Childs will be talking about culturally relevant pedagogy. And I think exactly here is where many teachers still need a lot of support, and I think it's also a relevant topic that will be addressed in a month. But regarding tool support, the teachers were quite positive. So they told us, well, Litterbox can help teachers to create good example programs, and most of the teachers agreed with that. And we then asked them, why do you think that Litterbox can help you? And they, for example, mentioned, well, that the functionality is positive, or 1/3 also had negative aspects about it. And I'll just show you some quotes what the teachers stated. So the negative comment deals with that Litterbox cannot analyze any semantics, but only looks at the code. So of course it has its limits there. Also regarding representation, there were both positive but also negative comments. But we found that in the more current versions of Litterbox, the negative comments luckily reduced and were significantly less than for earlier versions. And even though we didn't ask the teachers if they think that Litterbox can be useful also for primary school children, many of them said something about it. And about 20% were positive and about 8% were negative. And currently, I'm actually on the negative side because I think that maybe the Litterbox hints should be differentiated and so on. I will ask in a minute what your opinion is about that. But here you can see 2 comments on both positive and negative aspects. Where we really paid attention that the vocabulary is basic, but still correct. And we also have in the first line a hint on the mistake, because with the teachers we realized it's so important to have default localization. And additionally, on the right-hand side, you can see mark important words. By this, we try to engage the students a little bit, as we saw that also at university level, there have to be prompts so that you actually learn something by the hint, because otherwise you would just run through the hint and do what it tells, but not actually elaborate on it. So the hint on the top deals with an explanation of the concept, so it could be called a conceptual hint. We tried to make it about the basic concepts of the specific bug pattern, but it was quite hard to put the information needed inside of it and still be child-friendly. And the lower hint deals with the procedure, and here we tried to split every bug pattern up into 3 steps. So we're having find the buggy script, then improve it, and then test the corrected script. So actually the solution is the 3rd step, but we realized that only the 3rd step wouldn't be enough for primary school children because they may not see the difference between their buggy script and the corrected script. And still, I think it's important for them to know how to get there. We used these 2 types of hints in a study with 36 children in an after-school course. And while in the first 3 units, they got to know basic programming concepts, in the 4th unit, they were tasked to debug 6 programs. And it was important for us that every child received every hint. So for 2 programs, each child got a conceptual hint, for 2 programs a procedural, and for 2 programs either none or both hints. In the first courses, we also had this version with no hints, but we quickly realized that it's really frustrating for the children to actually not get any further without any hint. They could also couldn't ask us, as it was an experiment, and so we quickly switched to them having both hints. And I think that's also the case in the classroom, because you're running from one student to the other, and still some students are struggling at the same time and you can't get to them at the same time. So I think Litterbox might be helpful here, as long as it's adequate and appropriate for younger learners. So Unit 4 was all about how do children perform with our hints. We also had a 5th unit where we tried to capture the learning, but the results were quite ambivalent. So we are having both indications that learning with hints is better, but also learning without. So here more research is needed. So when we are looking at the performance regarding the correctness, we found that indeed the procedural hints were the best ones. Actually, not both hints, which I would have thought, but it seems that having an additional explanation is somewhat confusing and adds too much on the cognitive load maybe. And so procedural hints were significantly better than conceptual hints or no hints. We also wanted to look at the programming behavior, and we did this by looking at block events. So what kind of blocks were added, moved, and deleted during this whole process? And how often and when the children clicked on, for example, the green flag and tested their program. And while it would take a long time to do this manually, a colleague of mine and actually many colleagues of mine are working on the so-called scratch log tool, where we can track these events. And I hope I have some time for this. I will shortly give you an introduction into this tool. Litterbox is publicly available, but this tool also is, but it's rather hard to set it up. But I will still show you it. And if you're interested in it, you can just write me. I'm open for helping you. So Scratchlog is basically structured into courses and experiments, where you can then create users and have your own courses. And then I will show you the video now. You add the user data. So I log in as a learner. And then I see all the courses and experiments I'm in. And then I'm forwarded to Scratch. It's actually hosted by us, but it looks like Scratch. And now I can make some code changes. I know where the bug is, so I can do it quite quickly. And then I stop the experiment. And at the same time, Scratchlog saves all my code changes. And when I log in as an admin, I can see these changes. However, at the current state, there are only few visualizations available, but we are trying to integrate more so that it's more convenient. Here you can see that I finished the experiment and click on my results. Here are the block events. I didn't create 5 things. This actually is the scripts that were already inserted in the starter file. But here I can download all the Scratch files. And on the bottom, there's also some kind of visualization of the process. So here, not a lot has happened. But you can imagine how it would have been for us to manually analyze a lot of programs. It was, of course, way easier to just download the Scratchlog files and then analyze them with Litterbox, for example. You also get a file with all the block events, and we use that for this visualization. So we will just have a look at the last row. So those are the procedural hints. And in comparison to the other hints, we see that quite few blocks were moved. So the approach when getting a procedural hint seems quite straightforward. While this might not be the case then for other experiments, we hope that, of course, the children also get more into this systematic behavior, also by using the systematic hints, but there definitely has to be more research. We also looked at the click events, and here we'll have a look at the conceptual hints. And here we see that this student really often clicked the green flag. And this might indicate that they are in favor of testing their script very often. But for young learners, this might also show that they are following a rather trial and error based approach. So they are just trying things out and testing and doing this iteratively. And it seems rather unsystematic. But of course, maybe they are also elaborating on the explanation. And here it might be interesting to have more qualitative research look into it. It was also very important for us to ask the students what they think of the hints. We asked them how useful they think they were. And of course, usefulness for children might mean something different than for us. So for us, a hint is useful when the children learn something from it. For a child, it might also be helpful and useful when they just get to the solution, as they want their program to work. But still, we wanted their opinions, and here we found that they preferred to have indeed both hints, which is somewhat different to the performance we've seen before, where procedure was the best one. But still, procedural hints were significantly better perceived than conceptual hints or having received no hint. We also asked the children why they rated like this. And here some children also preferred the conceptual hints because I have to elaborate a bit on them. And with the procedural hints, the problem is we children are not challenged this way. So we can't say the procedural hint is the best for everyone. As it was also mentioned in chat before, we have some children that want this challenge. And other children said that, well, they can't envision the conceptual hints easily, and that the procedural hints with this 3-step composition really helped them. So what we can see here is that there's no one size fits all. I think there has much work to be done to differentiate the hints and get all learners to get their computational thinking, programming concepts promoted. So to sum up, we have seen some Litterbox hints in their current version and found that they are helpful for debugging at least most of the hints. They can be helpful for creating good example programs, and they also have an effect on the programming behavior. So I'm happy to discuss with you what ideas you have how to integrate Litterbox, for example, in your classroom.
And thank you to Luisa. I just really love the research that they're doing in their team, and say thank you for joining us, and we'll see you next time.